Hi all, greeting from Centum Academy. Welcome you all to the YouTube live session on 3D geometry. This is session 4. I hope you all have watched the previous 3 sessions. In case you haven't, then please do so that we make more sense from this session. So in this session, we're basically going to continue from our last session where we had talked about different aspects of planes and their equations. And we had covered many concepts related to planes and lines. So in this video, I'm going to start with equation of a plane in intercept form. So Naman, did we do intercept form of the equation of a plane?
No, sir.
Okay, fine. So we are going to start with the intercept form of the equation of a plane. So what is the intercept form of equation of a plane? You would recall that in 2D geometry, while doing the equation of a line, we had discussed about the equation of a line in the intercept form. In a similar way, you can also have the equation of a plane in intercept form if you know what are the intercepts which is cut by the plane on the x, y, and z axes respectively. So let's say we have these coordinate axes. So let's say this is my z-axis, this is my x-axis, and this is my y-axis. So please ensure that the axes that you have made is a right-handed coordinate system. Okay, that means if you swap your fingers from x to y, your direction of the thumb should be along the positive z-axis. Now let's say there's a plane which cuts the x-axis at A, which is at a distance of A from the origin. And let's say it cuts the y-axis at B. And let's say this is B from the origin. And let's say it cuts the z-axis at C, which is at a distance of C from the origin. Okay. So what I'm going to do is I'm just simply going to join these points A, B, and C just to make you feel the plane which is shown by this surface. Okay. Now I want to get the equation of this plane. All right. Now please note that when I say A, B, and C, they are directed distances. Directed distances means if I'm taking it along the positive x-axis, A is positive. If B is taken along positive y-axis, B is positive. And if the C is taken along the positive z-axis, then C is positive. That means A, B, and C are directed line segments. That means they can have their own signs. Okay. That means there's a possibility for A, B, C to be negative as well. So don't treat them exactly as distances because distances are always positive. They are directed distances. That means they can be negative as well. Okay. Now, how do I get the equation of this required plane? Okay. How do I get the equation of this required plane pi? For that, I already know the coordinates of A, B, and C. How? If it cuts it at a distance of A from the origin, I can clearly say the coordinates of A is small a, comma, 0, comma, 0. Similarly, the coordinates of B would be 0, comma, small b, comma, 0. And coordinates of C would be 0, comma, 0, comma, C. Correct? Now, I want to find out the equation of a plane which passes through these 3 points. If you would remember, we had already done, just let us recall this. We had done the equation of a plane passing through x1, y1, z1, x2, y2, z2, and x3, y3, z3. And what was that? Can anybody tell me? It was in the form of a determinant.
Yeah.
Do you remember that?
Yes, sir. Determinant of x minus x1.
Very good.
Y minus y1. Z minus z1.
Right.
x2 minus x1. Y2 minus y1. Z2 minus z1. x3 minus x1. Y3 minus y1. Z3 minus z1.
Excellent, Naman. Excellent. Very good. So we can directly make use of this determinant to get the equation of the desired plane. Okay. So in this case, my x1 is A. You can call these points as x1, y1, z1. This as x2, y2, z2. And these 3 points as x3, y3, z3. Right? So now let us complete the equation. So x1 minus x minus x1 is x minus a. Then we'll have y minus 0, z minus z1 is z. Okay. x2 minus x1 is going to be minus a. y2 minus y1 is going to be b. And z2 minus z1 is going to be 0. Okay. x3 minus x1 is going to be minus a again. Y3 minus y1 is going to be 0, and z3 minus z1 is going to be c. All right. Now let us expand this. When we expand this, we get x minus a times bc minus y times minus ac and plus z times minus of minus ab, which is plus ab equal to 0, which finally simplifies to x minus a times bc plus y times ac plus z times ab equal to 0. Okay, which can further be simplified as x bc y ac z ab equal to a bc. Okay, and if you divide throughout, if you divide by ABC throughout, we are going to get the final equation as x a plus y by b plus z by c equal to 1. And you would realize that this is very much similar to the equation of a line in 2D in intercept form. So at various stages of planes, you would realize that it bears a close resemblance with line in 2D. Okay, so this is just yet another example where you realize that it is very similar to x by a plus y by b equal to 1 equation of a line in intercept form in 2D. Let's have a very quick question on this, not a very difficult concept. Any question with regard to this derivation? Ramcharan, Kaudinya, Amog, Aditya? While those who are on YouTube live, please type in your name so that I know who all are attending this session. So just a quick question. Find the equation of the plane which cuts the coordinate axes at points A, B, and C respectively, such that the centroid of the triangle ABC is P, Q, R. Okay. Very simple and straightforward question. So there is a plane which cuts the coordinate axes that is the x-axis at A, y-axis at B, z-axis at C, such that the centroid of the triangle ABC is P, Q, R. Okay. Find the equation of the plane. I think it'll just take you 1 minute, less than that, to solve this question. People who have joined us on YouTube Live, request you to type in your names in the chat box so that I know who all are attending this session. Also, feel free to type in the answer in the chat box if you're done. And those who have joined us on Skype, you can speak out the answer.
So is it x by 3p plus y by 3q plus z by 3r equal to 1?
Absolutely correct. So pretty simple. Let us solve this. Okay. So the situation is let's say this is the x-axis, this is my y-axis, this is my z-axis. And we have a triangle which is formed by connecting these intercepts. Okay. Now the centroid of this triangle, let's say G is PQR. Okay. Hello Siddhant, how are you? Seeing you after a very, very long time. Hope you have done well in your exams. All right, so let this point A be A, 0, 0. Let this be 0, B, 0, and let this be 0, 0, C. So when I talk about centroid of a triangle, we all know that the coordinates of the centroid is x1 plus x2 plus x3 by 3, comma y1 plus y2 plus y3 by 3, comma z1 plus z2 plus z3 by 3. So according to my given scenario, where the vertices are A0, 0, 0B0 and 0, 0C, this should be A plus 0 by 3. This should be 0 plus B plus 0 by 3. And this should be 0 plus 0 plus C by 3. Now, of course, this is my P, this is my Q, and this is my R. So A by 3 is P, which implies A is equal to 3P. In a similar way, B by 3 should be equal to Q, which implies B is 3Q. And C by 3 is equal to R, which implies C is 3R. And a little while ago, we had done the equation of a plane in intercept form, which is x by A plus y by B plus z by C equal to 1. So putting in the value of A, which is 3P, I get x by 3P plus y by 3Q plus z by 3R equal to 1. Or you can also say x by P plus y by Q plus z by R is equal to 3. Plain and simple. No rocket science involved. Very simple concept. Okay, so this becomes your answer. Okay. Well, now moving on to next concept. I think we have not done the distance of a point from a plane, if I can recall it correctly. Please correct me if I'm wrong.
Yes, sir, we have it.
Okay. So distance of a point from a plane. So guys, we have done a lot of theory now regarding planes. So I would like you all to solve this question without my help. So let's say we have a plane pi. Let me give you the vector equation of this plane. The vector equation of this plane is r dot n equal to d. All right. And we have a point, let's say point A, whose position vector is A. Okay. And we want to find out the perpendicular distance of A from this plane. So we want to find out the perpendicular distance P of this point having a position vector of A from this plane. And not only that, I need the foot of the perpendicular, which is B as well. So two things I need here. One, I need the foot of the perpendicular. Okay. Foot of the perpendicular, which in this case is your position vector of B. And second of all, I need the perpendicular distance. This is a very, very important concept which is very regularly asked in school exams as well. Perpendicular distance, which is your P. So I would give you a minute or so to work on it. And do let me know the answers for these two by typing in the chat box or speaking it out in whichever way you want. Anybody having any idea? Ramcharan? Anybody having any idea? Kondinya?
No, sir.
No idea?
No, sir.
Okay, fine. So I'll help you out in this case. See, the first thing that we need to do is we need to get the equation of a line which passes through A, okay, and perpendicular to this plane. So I need to get the equation of this line. Okay, this line equation, let's say L, I need to get the equation of this line. Correct? Now you tell me, to get the equation of a line, what all things we need? We need a position vector on the line, which is already known to us. We need the direction to which the line is parallel to, which is also known to us because we know the equation of the plane, right? The plane is basically in such a way that it is the normal to the plane is along the direction of the line. So I have all the required information for me to write the equation of a line as r is equal to a plus lambda n. Correct? Right? Where what is lambda? Lambda is a parameter. Okay? Now I would say that for a particular lambda, let's say I reach the position vector of B. See, what is lambda? If you keep on changing your lambda, you'll get different points on the line. Isn't it? If I keep lambda as 0, I'll get the point A itself, which is a point on the line. If I keep as lambda as 1, I'll get some other point. If I keep lambda as 0.5, I'll get some other point. So let's say for a particular lambda, I reach a point B. Right? In other words, I'll say, let the position vector. Guys, are you there?
Yes, sir.
Yes, sir.
Okay.
Yes, sir.
Yeah. Let the position vector of B be A plus lambda n. All right. Now, I also know the fact that B satisfies the equation of the plane, which is pi. Right? That means in place of this r, if I substitute A plus lambda n, then my equation should get satisfied. That means A plus lambda n dot n is equal to D. Yes or no?
Yes, sir.
Okay. Now, if you open this bracket, it will become A dot n plus lambda n dot n is equal to D. Okay, which implies A dot n plus lambda mod n square is equal to D. So lambda is going to be D minus A dot n by square of mod n. Is that okay? Now let's replace this lambda back over here. And if I do that, I get the coordinates or position vector of B as A plus lambda, which is going to be this expression, times n. Correct? So this answers your first part of the question. This is the answer to 1. What is the position vector of point B? That is A plus D minus A dot n by mod n square times n vector. Please note that this is behaving as a scalar quantity. This is a scalar quantity. Okay. Any doubt regarding the foot of the perpendicular? That is the position vector of B. Any question, guys? Please speak out.
No, sir.
Would appreciate if you keep the session interactive. Okay. Good. Now, having got the position vector of B, what is the length of the perpendicular, or what is the perpendicular distance? You would say the perpendicular distance is nothing but mod AB vector, right? It's the modulus of the AB vector, correct? So what is AB? AB vector is nothing but position vector of B minus position vector of A. So which is position vector of B is already known to us, which is A plus D minus A dot n by mod n square times n minus position of vector of A, which is A itself. A and A gets cancelled off. So I'm left with D minus A dot n by mod n square times n vector. Correct? Okay. Now, what would be your mod of AB vector? Mod of AB vector will be mod of this, which is going to be mod of into mod of n. So mod n and one mod n will get cancelled off. So the distance will become D minus A dot n mod. Now this mod is the one which makes positive mod. It is not the magnitude, because this is actually a scalar quantity. So this is just to make it positive. Don't think as if it's a mod of a vector. So this mod makes it just positive, okay, divided by mod of n. So this is the result which you are supposed to remember. Mod of D minus A dot n, right? And take the modulus of it. Let's say if it is a negative quantity, take the absolute value of it, divide by the mod of n vector. That is the magnitude of n vector. Does it make sense?
Yes, sir.
Okay. Now, a couple of things here. If A becomes origin, you can see that your distance becomes mod D by mod n. This is something which we had already discussed also last class. So it is very much in line with whatever we discussed in the last class when we were doing the normal form of the equation of a plane. So this d, if you mod it and divide by the modulus of this normal vector, you are going to get the distance from the origin. If you refer to the note of the last class, you would recall that we had done this concept.
Yes, sir.
Okay. Now, let us do the same thing in Cartesian form. Right now, we dealt with the vector form of the equation of a plane. Let's say the very same thing comes in Cartesian form. Then what is the result? And let us keep that result in our mind so that we save time solving such problems. So now I'll talk about the Cartesian form for the same concept. So again, let's say we have a plane pi whose equation is ax plus by plus cz plus d equal to 0. And we have a point A whose coordinates are x1, y1, z1. Okay. So we need to find out this distance p. And if possible, we also should find out the foot of the perpendicular. Now again, the concept is pretty much the same. We are not dealing with any new concept here. It is the same thing, but now we are dealing in Cartesian form. So what is the first thing that we'll find out over here? Again, we'll try to find out the equation of a line which is passing through A and perpendicular to the plane. Okay, and what would that line equation be? The line equation would be x minus x1 by A, absolutely correct. Y minus y1 by B, and z minus z1 by C. And again, just like we did it in the vector form, I'll take a particular lambda parameter for which I get the point B. So what would be the coordinates of B? So you would say coordinates of B would be x1 plus A lambda, y1 plus B lambda, and z1 plus C lambda, isn't it?
Yes, sir.
This would be my coordinates of B. All I need to do is make x, y, z the subject of the formula in this symmetric form of the equation of the line, and I get the coordinates of B. Now, how do I get the lambda value? By the simple fact that B satisfies pi, that is the equation of the plane. So A times x is nothing but x1 plus A lambda, B times y, which is nothing but y1 plus B lambda, and C times z, which is z1 plus C lambda is equal plus D is equal to 0. Correct? So which gives me ax1 by1 cz1 plus D plus lambda a square plus b square plus c square equal to 0. So your lambda becomes negative of ax1 by1 cz1 plus D whole divided by a square plus b square plus c square. Okay. So guys, one thing I have got these points. If you substitute your lambda from, let's say I call this as first equation. So substitute your lambda from 1. Okay, you will get the coordinates of B. Right now you don't need to do it. It will result into a very ugly expression. So we know what is the lambda value. We know x1, we know A. So just substitute it and you get the coordinates of B. No need to do it. Now let us go and find out P, the perpendicular distance. Now if you know this point B has a coordinate of x1 plus A lambda, comma, y1 plus, y1 plus b lambda, comma z1 plus c lambda, then your distance AB is going to be, okay, x2 minus x1 square, which is a lambda square, y2 minus y1 square, which is nothing but b lambda square, and z2 minus z1 square, which is nothing but c lambda square, under root of this whole thing. Under root of this whole thing. So this is going to give me mod lambda times under root a square plus b square plus c square. And lambda is already known to us from 1. So from 1 we can substitute lambda. So it will be mod of ax1 by1 cz1 plus d by, there is no need to put a mod on a square plus b square plus c square because it is already a positive quantity, times under root a square plus b square plus c square. So you can cancel this off and put a under root over here, right? So you can remember the distance of the point x1, y1, z1 from the given plane pi
Is it working on YouTube?
Yeah. Can you guys hear me?
Hi, sir.
Yeah, I'm sorry
Yes.
we lost connection. Now we are back. Let me share the screen with you. Yeah. You see the screen now?
Yes.
Okay. Can you all see the screen? No problem with that?